the same team of researchers that last week took the James Webb Space Telescope's JWST first direct image of a planet outside our solar system has confirmed the presence of smoke-like silica clouds in the atmosphere of another. Hypothesized for many years, the finding published in a new, non-peer-reviewed, paper reveals that an exoplanet called VHS 1256b has a violent and turbulent atmosphere that is filled with clouds. Except that these clouds are not made from water vapor droplets, but smoke-like particles of silicate. A better way to think of these clouds are objects that are made of tiny particles. Except that these silicate clouds are made of the same thing that grains of sand are made of, said Sasha Hinkley, Associate Professor in the Department of Physics and Astronomy at the University of Exeter in Princeton. Astronomers that model exoplanet atmospheres using computers have predicted for decades that these smoke-like particles should exist in these atmospheres, but only JWST has the wavelength coverage to definitively detect them. As well as clouds, the team also found carbon dioxide in VHS 1256b's atmosphere, just days after JWST detected carbon dioxide around another exoplanet for the first time. This second time didn't make the mainstream news, which helps put these findings in context. JWST is currently being put through its paces as it's used to make the first ever infrared observations of the cosmos, so expect a bunch of firsts in the next few months. For example, they also uncovered a turbulent atmosphere on VHS 1256b. In a calm atmosphere, there is an expected ratio of, say, methane and carbon monoxide, said Hinkley. But in many exoplanet atmospheres we're finding that this ratio is very skewed, suggesting that there is turbulent vertical mixing in these atmospheres, dredging up carbon dioxide from deep down to mix with the methane higher up in the atmosphere. This discovery of disequilibrium chemistry on a VHS 1256b is a pretty weird place. Orbiting not one, but two brown dwarf stars that themselves orbit each other. The planet does not orbit its binary host in a circle, but rather in a very oval eccentric orbit. It's 72 light-years from the solar system in the constellation of Corvus. It's somewhere between 12 and 16 Jupiter masses, which is so big that it's a candidate failed brown dwarf star rather than a planet. So the paper actually refers to it as a planetary mass companion rather than simply as a planet. It is definitely not terrestrial, said Hinkley. It's much more like a gas giant, super Jupiter object. Either way, this object is roughly 360 times our Earth-Sun distance, away from its host star, so takes a whopping 17,000 years to orbit it.